the following is a tutorial on doing thermochemical equation calculations. Okay, so let's start with an example where we are calculating the amount of energy. So when hydrogen peroxide is placed on a cut knee, it decomposes to form water and oxygen gas. How much energy will be released when 34 grams of hydrogen peroxide, so H2O2, decomposes according to the following equation? All right, so we are starting with mass of hydrogen peroxide, okay, and we are asked to find the amount of heat that's going to be released. So we are going to go first from grams of hydrogen peroxide to moles of hydrogen peroxide. We're going to do that using molar mass. Okay, so on the bottom, we're going to have grams because we have grams of H2O2 on the top, and we are looking for moles of H2O2. All right, and so we're going to plug in 1 mole here because the molar mass is the mass of 1 mole, and then I look up the molar mass of hydrogen peroxide. Hydrogen has a mass of 1, and there's 2 of them. Oxygen has a mass of 16, and there's 2 of those, so 2 plus 32, you're going to get 34. Okay, so we're actually already starting with 1 mole. Okay, so these units are going to cancel. 34 times 1 divided by 34 equals 1 mole of hydrogen peroxide. So now we're going to go from moles of hydrogen peroxide to the amount of heat that's going to be released, and what we're going to use is ratio of coefficients with enthalpy. So I have moles of hydrogen peroxide on top, so moles of hydrogen peroxide is going to go on the bottom. And the number of moles of hydrogen peroxide that react is 2. Okay, so remember that the coefficient represents moles. 2 moles of hydrogen peroxide decomposes to form 2 moles of water, 1 mole of oxygen, and 200 kilojoules of heat. So we've got 2 moles reacting, okay, and then the coefficient that we use for heat is enthalpy, which is 200 kilojoules. So 200 kilojoules of heat is released per 2 moles of H2O2. Okay, 200 per 2 moles of H2O2. So we're going to multiply the numbers on the top, 1 times 200 divided by 2, and your answer will be 100 kilojoules. All right, if we were to put that using correct sig figs, it would be 1.00 times 10 to the 2 kilojoules. Okay, our next example, manganese will react with hydrochloric acid to produce hydrogen gas according to the following equation. So you've got 1 mole of manganese reacting with 2 moles of hydrochloric acid to form 1 mole of manganese chloride and 1 mole of hydrogen gas. Okay, and then we're also producing 221 kilojoules of heat. So the question says, what mass of HCl is needed to produce 663 kilojoules of energy? Okay, so we are starting with energy. We're asked to find mass of HCl. Okay, so we're starting with energy. So first we're going to use enthalpy and ratio of coefficients to go to moles, and then we're going to be able to go ahead and convert that into mass. So 663 kilojoules of energy. So I've got kilojoules on the top, so on the bottom of my next step I will also have kilojoules. So again, we're using enthalpy with ratio of coefficients. So the amount of energy is 221. So 221 kilojoules will be released per 2 moles of HCl. So we're trying to find the mass of HCl, so first we need to go to moles of HCl. All right, so kilojoules will cancel out. So what we're saying here is that for every 2 moles of HCl, we form 221 kilojoules of heat. So I'm going to multiply the numbers on the top, so 663 times 2 divided by 221. And your answer is 6 moles of HCl. So now that we have moles of HCl, now we can go ahead and convert that into grams using molar mass. Okay, so I have moles of HCl on the top, so moles of HCl will go on the bottom. And for molar mass, we're looking at the grams in 1 mole. So I'm going to go to my periodic table, and I find that the mass of hydrogen is 1, the mass of chlorine rounds to 35 to the nearest whole number. So hydrogen's 1, chlorine is 35. So altogether, our molar mass is 36, and that's the grams in 1 mole. Okay, so multiply the numbers on the top, 6 times 36, and then we're dividing by 1. Your answer is 216 grams of HCl. And we already have that in the correct number of significant figures, 3 sig figs, 3 sig figs.